Okay, we're still working on agent movement, and we have a problem because last time I succeeded in making an agent that can um, navigate on its own and avoid falling off the floor, as well as avoid running into objects. Let's take a look here. Here's our agent, and he's just kind of randomly moving around, and when it reaches to the end of the floor, it will say, oh, there's no floor there, let me try to go somewhere else. And it's just kind of randomly rotating. There's no floor there, so choose another place. And if you put something in front of it, let's say I can actually maybe do this, transform this and put it in its way. Let's see. Put this here. Yeah, so it can't go through it. It went around it. Let me go up. Whoops. Yeah, you can't go through it. What? Did it go through it? Let's see. One thing I don't like is kind of jerky. It goes a certain distance and then it just kind of stops and then it changes. Well, that's weird. Sometimes it just does a huge spin around. And then it kind of gets stuck here because it got a sample. And so it's quite noisy for the amount of events that it has to emit. Let's see if I can just ram this in front of it. I'm going to trap it over here. Whoa. And you should be getting trapped. Okay, so that is cool, and that respects obstacles. Oh, it somehow got past it, but now it's trapped in there. So this is going to produce a lot of messages. So this is kind of what I want to fix. Okay, so the problem with this is that we just picking a direction and there's no rotation. So when we rotate locally, the only messages we were able to send is when an agent spawned, and then it's just directed to a position and it'll automatically rotate. So there's no message for rotation in here. The rotation is implicit. We can receive hits, but when we do find an obstacle, I think we need to stop. So a missing message is that agent should be stopped. So let's add a message for that. Agent directed, agent hit, agent stopped. We'll add a type for this here. Which agent? And the position you have stopped in. Alright. And the algorithm. So the algorithm right now is just pointing in a random direction, and it just starts moving. And then it just sort of poking. It's kind of poking. Can I go here? Can I go here? And I think we need to be more discerning with our messages. So our new algorithm should be find a, maybe calculate find random eligible position that is at least 5 meters away. If none can be found, it just doesn't move. You won't get any new message. Don't move. And the eligible position has no obstacles up to that point, and the point is on the floor. So we could kind of take our random point calculator and just say generate a random point that's far enough from my current position. So it's got to be greater than or less than a certain amount of x and z. Then for every point, check if it's on the floor. If it's not on the floor, then we'll consider it not reachable and find another one. If it is on the floor, then we'll see, is there a point? Is there something in front of it? So we cast a ray from our current direction toward that place. And if both of these conditions are met, then we'll go there. That'll stop us from poking around, because the moment we start off on it, it's already a good place. And then if something does get in our way, we need to stop and then not automatically start up. So a stop should not, or should it? Because if that obstacle is removed, don't you want to keep it going? So maybe that's okay. It's just part of its cycle. So let's fix this problem first. Give me a second. All right. Let's look at agent. We have a update loop. And it was, okay, we need to recover some of the code that we had here. So this will try 10 times in order to get a random eligible point, or maybe no point. So we'll try 10 times. Starting off with 10, every time, as long as tries is greater than 0, we'll reduce 1 from tries. And then, so the random x and y was here. The current position, plus 10 minus 5 gives you a range of 5 plus or minus. But we actually want to be at least 5 away. So this would be within 5. So to push this further away, I think we could do 20 minus 10. That would make the random point reach from plus or minus, let's say you're at the origin. Multiplying something at the origin would be, let's say, a random point. Multiply that by 20, gets up to, let's say you got the extreme. Let's say you got 1, that will give you 20 minus 10. That will go from 10 to negative 10. It's still within the range of 10. So that's not what I want. I want it greater than that. So how do I pick a number that's not within a range, but greater than a range? Let me think about this. Okay, I think we need to take the sign into consideration. So let's calculate a random number for x. So let random x be a number for the amount of boost. So let's say we want a number between 10 and 5. So that'll be multiplied by 10, subtract 5, which would give you, let's see, 0 through 9, well, almost 0 through 10 minus 5, which gives you between 5 and negative 5. Okay, and same thing for random z. Okay, so this gives you a number from 5 to negative 5. Right, and you can just test this here. So you get up to negative 5 and up to positive 5. Yeah, seems like that's what it'll do. And then we want to boost this number, saying, so we need the sign. So if let x sign be this transform position in x. If it's greater than 0, let the sign be positive, otherwise let it be negative. And the same thing for z sign. And so, or let's let this be offset. See, offset. It's not an offset. It's more like a buffer. And so this would be 5 to negative 5, 5, and negative 5. And you just add that buffer in there. So you say, let the x be plus the x buffer. So if it's positive in any way, it's just more positive. It occurs to me we could just use multiplication for this. We could just say multiply it by a certain random percentage. That might work too. And then you could keep it between this and there, but it'd be harder to scale it because it's not. The bigger the number, the bigger the proportion. So if they're far away from the origin, this random number gets way bigger. So let's just keep doing what we're doing here. So we have a z buffer. This way the random number is always kind of constant. So we're adding this z buffer and x buffer. That means that if I'm, let's say, negative 23, then I'm saying make it more negative 23 by 5. Add 5 to it. Wait, what does that do? That's going to push the number negative and then multiply it by, and then add a random number. Actually, the random number has to be either give me a second. Actually, I think this is a wrong approach. I think I have a better idea, which is to, let's go back to the way we were doing it before, which was math.random and dumb. And then you multiply it by 10, subtract 5. That gives you some random number between 5 and negative 5. And because we want it bigger than that, let's just multiply that by 2, because that'll certainly double that random number, which is the same thing as doing this, right? So I think I was correct in that the random number here, let's see, should not be a number smaller than 5. Of course, there's a counterexample here. Let's see, do we get much smaller than 5? Yeah, we still do. We still do. Okay, so multiplying a small number, doubling it, it's still within the small range. So you need some kind of subtraction in there, because this still produces small numbers. Okay, so if the random number is less than 5 or negative 5, well, I guess you could do this. Put the random number multiply 5, but you want a bigger number than this. So if the random number is less than 5 here, add 5. So if you just did that and you added 5, you'll always get a random number bigger than 5. Um, and then randomly you can so with this you need to have it sometimes be positive and sometimes be negative. No. Oh, no, we're going to add. Greater than or less than a number. In a specific range. Max, min, plus min. Oh, okay. So max of 10 minus a minimum of 5 plus 5 is the same thing as not being able to generate random numbers. That's kind of what we're doing. So we have to do another one if we want. Maybe if you get a bigger random number and then a smaller random number, and you subtract them, then you'll get the range. Okay, I was thinking about this for a while and I don't see any way around it. We kind of need a random sign function that will just return random 1 or -1, and then we'll just flip this random number. So we'll get find a number between, let's say, 10 and 5. So let x random will be math random, and it'll be multiplied by 10 and subtract 5. That gives you a number between 10 and 5. And then the whole thing multiplied by this random sign gives you... What's the matter with this thing? Math is used before sent to declaration. No, I think it's just the issues with this. So then here you add x random, and then this can be y random. Alright, so that finds a random point. Then you got to check to see if this point's on the ground. But first you got to see if there's any obstacles. So we can say this, let's see, rotate or something. Floor detection ray. So we need to cast a ray from the current position to this random point and see if there's any obstacles. So we need a function for that. We had one that was called there's a forward ray. We have like a rotate ray. Convert direction. Okay, we have something similar. So we need to create a ray, something like this. So this would be check if something's in the way. So let's create obstacle ray. We need the test point, which will make a Babylon vector 3. And we'll do this business here to see if there's something there. So first we draw a ray origin from our own point. We got to raise it up a bit, so this ray origin y be this transform position y. Since it's on the floor, let's just make it like 1.1 meter tall. And then the direction will be this point minus the whatever. Test point, subtract this ray origin. Test points on the floor. So we need to let's modify test point as well. So let's say this target. Well, let's say test point is the right height. If you take this minus the test point, that will give you a beam that goes from here to whatever point. But I feel like we need to scale ray in a certain direction. So I don't think we need this matrix stuff, actually, because we don't need to rotate it. But we do need to maybe move the origin. So move origin so it doesn't intersect self-mesh. This ray origin scale which direction do we scale this? How do we do this before? Let's say bullet manager. Oh, we did an add in place and we scaled the direction. It's clever. So this is what we did. This ray direction scale by just do it so move it like 1 meter, I guess. Everywhere. Let's see what that does. Create obstacle ray, and let's just freeze this so it doesn't move. And I just want to know what that does. So there's our thing, and the thing we want to test is get random agent, and the function we want to call is check if we want to create obstacle array. Create obstacle array, and we give it a Babylon vector 3 from array, and let's say we're going with 5, 0, and 5. Okay, I think it went underneath the floor. You can see a little bit over there. Oh, okay, so it's beneath the floor. Let's make this 1 meter tall. Okay, so let's do it the other direction. So it was -5, -5, and okay, there it is. Oh, it's like quite far. Quite far. Right, let's come down a little bit. Yeah. So our scaling's quite a bit off. If we don't scale this in place, do we intersect ourselves? Oh, I think we do intersect ourselves. We just need to move this by... Okay, so this direction, maybe we just say that this direction is the unit, so normalize. And then this one, scale by 0.5 meter. Okay, moved it a little bit more. 1 meter then. Okay. That's our beam. Great obstacle ray. And where's the test point? The test point is all the way over here. So actually we just want to maybe normalize it here. Normalize this part. Scale this by 1 meter and keep this non-normalized. So this would go to the point that you want to go to, which is 5 by 5. I see this because you normalize in place operation. So if you want to do maybe a clone, then normalize. That seems a lot farther. So we have origin. So, okay, we didn't specify the length actually. Direction is, we haven't even used the test point yet. Oh no, test point, subtract this. That's the direction. So the length of that should be the length. Is there a way to, other way to make this? This ray dot length origin. Let's call this a direction. So cut const direction equals this. Why is it so long? Okay, so let's say origin is Babylon vector 3 0. If you do this target, whoops, let's just say target is equal to new Babylon vector 3, and you got -5, 1, and 5. If you just subtracted these things, the length is not going to be that long. So target subtract origin and give me the length. That's like 7. But this, okay, this ray, it should return the ray, right? Okay, we need to return the ray. Return this ray. And that ray length, create obstacle. Well, what is this? It's a ray, right? R equals this. R dot length. Oh yeah, it's 7. So maybe it's the helper that's wrong. Let's just do this, copy from. And then do that. Yep. And direction is this minus that. And then this is copy from. And then becomes this length. And then we move that. Okay, so maybe we'll just say direction. Normalize scale. I still don't understand why it's so long. The length is very long. What if the length was just 1? Maybe we don't need to set the length. Oh, it's assuming direction is normalized. If direction isn't normalized, then maybe you don't need to set that. This seems right. This is okay. Let's just set it to -1 and -1. Let's go up. Go up. Okay, that doesn't seem like 1 though. Well, it's shifted over, but okay. What's the length of this? 2? I think you can make an array out of a vector 3, right? Okay, so which one of these is vector 3? This is a vector 3. Can you create an array from this? Or maybe Babylon array can be made from a vector 3? This Babylon array dot create new from to origin and end. Okay, that's what we want. So Babylon vector 3 from array this transform x this transform y plus 1 this transform z from here to the test point. But I need a bit of a direction. So okay, so we still need some kind of origin. Let's let origin equal Babylon vector 3 copy this transform position clone, and then say origin y plus equal 1. And then we can say that the direction is indeed from the test point, subtract this origin and normalize, and then we can add in place. We can origin, add in place that direction scale by 1. Then we want to create a new array between origin and the test point and return this. That new array. And because we want to see it, we can say this array origin copy from new array origin this array direction copy from new array direction return this array. Do I need to set the length? This array length copy from new array length. We might not need it. Let's see. Maybe we do, maybe we don't. Ooh, I think we do. Yes. -1 is exactly the point we ended up, and we are 1 from there. So if we end up with a bigger difference, yes, I think that is correct. Let's go up, sorry, fly upward, look over here. There's about, yeah, 5 by 5s around here, and you got pushed over. I think it's aligned. It's hard to see if we're right above that. So let's go over this again. So you get the origin, clone from our current position, moved up, and the direction is just normalization from the direction we're headed toward, and this origin. Add in place. Okay. Then create a new ray between test point and origin. And so our length should be, what's our length? Should be less than 5. It's 6. Oh, well, it's 5 by 5 is square root of this. Okay, so what if we did something that goes like that? What's our length now? 4. Okay, yeah, that's correct. Alright, so we can create an obstacle array. And we also need to check if something intersects the ground. We have a function for this. Check if the point is on the ground. Test X and test Z. Okay. So we lift up to a head position. And then we create a ray that's looking straight down. Then we do a scene pick with ray. And then if it's hit, and okay, so this checks out fine. Check a point on my ground. Maybe we can use that. We could just say check if destination has obstacles. Well, I like this function though. But we should do this. Check if destination has obstacles. Takes a test X number, test Z is a number, and then we'll get array. Const test array will be this create obstacle array, passing in the new Babylon vector 3, which would be a test X, a this transform position Y plus 1, and test Z as the vector, and in the test array, then we would say, yeah, get a pick info if anything's touching this. So const pick info equals this scene pick with ray, test ray, and return if the pick info is a hit. Yeah. If you hit anything, you have an obstacle. Okay. So back to our random point or null, you get a random point plus a random sign, and then here's this. And so if the point's on the ground, let's first check if there's an obstacle. This, check. Let's just say it has obstacle. This. Well, they both say check. Check if destinations are check. The point is on the ground, true, and destination has obstacles, X and Z has to be false. So no obstacles, and the point is on the ground, and we can return the new destination. Which actually it shouldn't be this, it should be the Y of this. So point is on my ground should give back null. So if this is true, return pick info picked point Y, else return null. Has obstacles. So if there's a hit, why don't we just return pick info, else return a null. And then in the random point, let's check let ground height equal this, check a point on ground with X and Z, and if ground height, do something which is this. Let me proceed if there's a ground height. If there's a ground height, now we check if has obstacles. If it doesn't have obstacles, then this and return ground height. Otherwise, you don't do anything, we decrement this, and we keep trying again for 10 times, looking at all positions that are at least 5 meters away from us. If we don't find a position within 5 meters, we just sit pretty, we don't do anything. So this is random point or null, and we put that back into our event loop. So here, we're going to go someplace new if we can, or just sit here. So random point becomes this random point or null, and then if there's a random point, then we create movement to go there. Otherwise we don't do anything in update. We'll try again at some other point. In fact, it's constantly running, so we'll try again pretty soon. I think we'll keep trying. So let's enable this and see what happens. So it went at least 5 meters away. That didn't seem like it went 5 meters. Maybe it is 5 meters. We can check. We'll just output the calculated, add some more messages here. So when when we do find a point, let's say random random point. If there's a random point, console log the distance. Console log distance of new point is random point, subtract this transform position, and give me the length. Okay, this was just kind of 4, 9. Oh, went up. Oh. Okay, still doesn't go through things, still doesn't run off the floor. But it's calculating that, so we're getting a lot fewer messages. Now it might be stuck. It can't calculate a new position. Because all of these, I think, are less than 5 meters away. So unless we move this away, I don't think it can go anywhere. Let me see, maybe it's locked. Random agent, tell me about yourself. Locked is true, so it's just exiting. Okay, so it might have gotten something that set itself to cancel, but it kept the lock as true. Okay, let's take a break here.